So hello everyone, my name is Tulika Mishra and I'm going to deliver a very short lecture on cardiac cycle. So with the help of OneNote that I have prepared, I'll be delivering the lecture. In this lecture, we'll be covering what cardiac cycle is, what is it, why is it called so, what are the events that are involved and how long those events are. So let's begin the chapter without any delay. So as you can see also on your screen, if we talk about cardiac cycle is basically the human heart goes under constant rhythmic relaxation and contraction. The contraction is basically the systole that we are talking about, whereas the relaxation is the rhythmic diastole that we are talking about. We will talk about these words or these literal meaning of these words in the next para. The sequence of event that occurs during the same is known as cardiac cycle. So the rhythmic contraction and relaxation of heart and what goes inside heart is basically the cardiac cycle that we are talking about. If we talk about what do they really involve, there are two basic sets of event that basically involve in this. The very first of which is systole and the second is diastole. So just like I have told you in the previous section as well, systole is basically when the heart is actually contracting. As you can also see in this figure, when the heart will contract, it will push away the blood which is contained inside the heart, right? If we talk about diastole on the other hand, it is basically the relaxation of heart. So relaxation, if anything is relaxing, it is increasing its area, it's increasing its volume, thereby acquiring more and more blood inwards. So as you can see, the arrow are on the inside in here, that literally tells us the fact that diastole has happened, right? So moving on with the discussion, let's discuss what basically happens when heart goes under diastole and systole. So let's start the cardiac cycle first by understanding what happens during diastole. Let's start from diastole, because when diastole happens, the blood is drawn inside the heart. So let's talk about what happens when diastole happens. So blood returns to atria of the heart through the pulmonary veins and vena cava. So remember, whenever the heart expands, atria is also expanding. Atria is basically these two upper areas of heart, right? These are known as atria, whereas the lower compartments are known as ventricles. So whenever the heart is relaxing, remember, the diastole is basically the joint diastole in which atria also relaxes, ventricles also relaxes. So whenever atria is relaxed, just imagine if atria is becoming relaxed, the blood is basically drawn. So what are the sources of blood in this? Pulmonary vein and vena cava. Vena cava will be carrying deoxygenated blood from all the parts of the heart, whereas pulmonary vein are the one which will be carrying oxygenated blood right from the lung, which have been purified or oxygenated in general context. So as atria fills, the pressure inside them rises. So if let's say if we have a balloon, if we just put a lot of water inside the same, the pressure inside the same will increase. Just like that happens with heart as well. So we are putting a lot of blood in there, that is basically increasing the pressure on the inside. So blood moves. Whenever the pressure is increased, we have just one way through. Okay, so the pressure inside atria has increased, that will draw the blood towards the inside. Remember one more important fact, that 70 to 80% of blood is something which is drawn to ventricle from atria because of the gravity in the first place, whereas there is small amount of atrial pressure which will also draw the blood from atria to ventricle. Is that clear? Okay, moving on to the next part of discussion, the valves. So we have quite few valves inside heart. Which one will close and which one will open is decided by what phase of cardiac cycle the heart is in. So semilunar valve in the aorta and pulmonary valve artery close, accompanied by the characteristic dub sound that heart basically produce. So whenever the semilunar valve. So semilunar valve, as the name suggests, semilunar means half moon shaped. So half moon shaped valves are found in the major artery which is connected right from the heart. The major arteries and veins include aorta and pulmonary artery. Okay, so they are directly connected by heart and they are guarded by semilunar or semi moon shaped you can say valves, right? So they basically become closed and the closure of the same produces a characteristic sound which is dub. Always remember, during diastole the dub is produced, the reason being semilunar valves is something that is basically getting closed. Okay, so now let's talk about these are the events that we have discussed. Also, Semilunar valves is something that is closed, whereas AV valve is something that opens. So AV valves is something which opens. AV valve is basically atrioventricular valve, which will push the blood from one place to the other. Okay, that is present between atria and ventricle. It will basically push the blood from atria to ventricle because the doors are open, so the blood will be drawn. Is that clear? Moving on to the next part of the discussion, that is what happens during systole. Okay, one more thing. The joint diastole is about 0.4 second long, whereas the systole is divided into two parts. The atrial systole and ventricle systole at different times. So atrial systole is about 0.1 second long. So the contraction of atria wall along with the recoil of the relaxed ventricular wall. This is an important point. You'll have to remember whenever the atria contract, there is a relaxed, or you can say recoil movement by the ventricles, and this forces the blood into ventricle from atria. Of course, if the contraction of atria is something that is happening, it will push away the blood from the atria to that of ventricle, right? So it will be pushed through the ventricles, right? So throughout this stage, the muscle of the ventricle remains relaxed. This is an important point. Even though atria is contracting, the ventricle will remain relaxed and the blood is withdrawn. Then we have the second important part, that is ventricular systole. So why is the ventricular systole important? Because it takes 0.3 second. It's about 0.3 second long or so, and it is very important because it is the one which will push away the blood from heart to the different important veins, and it produces the very first sound of heart, that is lub. We will talk about it in the later part of discussion. So after a while, ventricle filled with blood have increased pressure. So remember the ventricle that is out there, which will be having increased pressure. Also, in the previous one we had, that is diastole, we had AV valve open. In here we will be having open valve closed. Why? Because we'll have to push blood from ventricle to the that of the artery, to the veins, right? To the respective blood vessels. So in order to do that, we'll have to make sure the blood or the door which is connecting atria and valve must be closed. So in this case, AV valve will be closed and semilunar valve will be open. Whenever AV valve closes, there is a characteristic lub sound that is produced at the beginning of this particular ventricle systole. Whenever it happens, the lub sound is produced. Remember this. And following this, ventricle contract, pushing the blood into aorta and pulmonary artery. So in aorta, the oxygenated blood will reach. In pulmonary artery, we know deoxygenated blood will basically reach, completing the circle of the pulmonary circulation, and aorta will complete the systemic circulation. Now let's talk about the time that is consumed by each of the steps that we have talked. Aortic systole is about 0.1 second long, as I have told you. Joint diastole, because atria and ventricle relax together. So that is why they are known as joint diastole, is about 0.4 second long. And then we have ventricle systole, which is 0.3 second long. So here we have a representation of the same. Here we will be talking about the pressure. So aortic, here we have three representation: the pressure in aorta, ventricular pressure, and atrial pressure. So let's talk about aortic pressure. So of course, aortic pressure, when the first sound is produced, it will basically decrease. When the second sound is produced, because the aorta will be filled with blood at this moment, the blood will be filled in aorta, so the pressure inside the same has increased. Here you will be seeing a relaxed stage. This is basically because of the elasticity of aorta. There is a dip in this at this point, just like we have discussed. So talking about ventricular pressure, however, when there is absolutely no blood, the zero pressure will be there, the green one that you can see. As the blood is withdrawn, the pressure will keep on increasing, and as soon as dub is produced, it will be again pushed to the major arteries, thereby decreasing the pressure inside the ventricle in the first place. Atria, on the other hand, it goes through, you can say, a sort of pressure changes, but it's not much significant compared to ventricle. Ventricle are under more pressure compared to atria. So atria is basically increased. You can see whenever the blood is withdrawn, it will basically increase the pressure, and when the blood is basically pushed, the blood is pushed away from the ventricle, the atria is gaining blood in here. So this is why a bit increase in pressure of atria is seen here. So this is just a graphical presentation of what we have learned till here. First hard sound is known as lub, and the second one is known as dub. So I hope that I was able to deliver the lecture and you were able to understand the lecture in the first place. For now, let's call it a day and have a great day ahead of you. We will meet soon, and thank you so much for your attention.